Hi everyone, welcome to the video. We are going to solve divisibility tree. So I will not read this problem statement since it is quite confusing and is not explained clearly. I will explain you in a better language. So in this question you are given, see the image. You are given an array tree. You are given an array tree. Okay. Now what you have to do is you have to remove few edges. You have to remove few edges such that after removal of those edges, now all such remaining trees which will be formed, now all those trees should have even number of nodes, even number of nodes. So see in example 1 this image, so there are 10 nodes, okay, and 1 is the root. Now here if you remove 1 to 3 and 1 to 6, then 3 4 will a tree of node 3 and 4, two nodes. Then 6 8 9 10, then again a tree with four nodes, and then 1 2 5 and 7, this will be formed with again a tree with even number of nodes, four nodes, as you can see the image. So here you need to remove two edges. So the minimum number of edges which you can remove such that all the remaining trees, disjoint trees, will be having even number of nodes. Okay, this is the best I can explain, otherwise the explanation given in the question is very ugly, is very bad. Okay, so coming back, see the example 2. Here you don't have image, but you can visualize. See, you have 2 connected to 1, 4 connected to 2, and 1 connected to 3. So 1 can be a root. Then from 1 you can imagine there are two nodes, 2 and 3, and then from 2 also you again have a node going to 4. So if you remove 1 and 2, edge between 1 and 2, then 2 and 4 will be connected. We will be having even number of node with this 2, and then again 1 and 3 will be connected, which will be having even number of nodes, again 2. So how we will do this question? How will we do this question? First of all, I'll create an adjacency list. So we are given in this manner edges format, which is connected to what? So I'll create an adjacency list. Fine. So I created a 2D list, empty. Now we will populate this adjacency list, e1 minus 1, append the element, first element of that, and here append the second element. Fine. Now store a variable result, and we will use DFS to go further down. I will name it utility. Start with adjacency. Now this is what you have at current position, v number of nodes, and then the third parameter is the parent. Okay, initially we do not have any parent, but as we go down we'll get the parent. Cool. At the end return the result, the first element of the result. Now we will form this DFS function, utility function. Fine. So adjacency, u node, and p is for parent, and then result. Fine. So I will store a count variable initially with 0. So this will count the number of nodes in a particular tree. So as we remove the edge, and they will become disjoint. They will become disjoint. So we'll count the number of nodes. Okay. Now we will traverse v in adjacency u for v nodes in vertices in adjacency u. If v is not the parent, if this is not the parent, go down, because if this were parent, you don't have to do any such thing. So you'll recursively call the function this time. Then we will be your child and you will be your parent because you came to we from the you, right? Now now this particular node, so what x will give you, this will give you number of nodes. So it is even if it is even the number of nodes for this particular tree is even, then okay, add it. Otherwise, if it's not even, store the count of nodes. Okay, so recursively you will keep doing this, keep calculating, keep going down, calculating the value of number of nodes, and if it is even, append the value. If it's not, append the value of nodes which you have currently. At the end, you will return count plus one, count plus one. Okay, because that will be one will be for root node. It is saying I have done some mistake. Okay, my bad. It's not a, let us submit and check the efficacy of our approach. Okay, again, let me pause for a moment and recalculate. So that is one mistake we did. This is not in the loop. The loop is only to populate the adjacency using the edges, and this is separating. That is what I did wrong. Yeah, as you can see, it does the job pretty effortlessly. So I hope you enjoyed the video and learned a new concept. And this was the best explanation for this question because the question itself is very unclear and hazy. You'll have to use your previous experience in order to understand what it actually wants you. So I hope you enjoyed the video and learned a new concept. Thank you. Have a nice day.